Welcome back, everyone. In the previous part, we introduced basic properties in C# and understood how they help us control access to data fields. Now, we'll go even deeper. We'll cover different kinds of properties like read-only and auto-implemented properties. We'll understand how C# handles multiple objects behind the scenes. We'll learn about the magical this reference. And finally, we'll explore constructors, special methods that prepare your objects at birth. This part is crucial because it will teach you how to design powerful, safe, and efficient classes. Let's continue. Let's begin by revisiting setters, or mutators. A setter method typically does two simple but critical things. It takes one parameter, the new value you want to store. It assigns that value to a private field inside the object. The naming convention is to prefix with set, followed by the name of the variable. Setters allow external code to modify private fields, but under controlled conditions, a key part of good encapsulation. Now, C# gives us a smarter and cleaner way. Properties. Properties look like fields when you use them, but they actually behave like methods. Standard naming rules. Use the same name as the field, but capitalize the first letter. Example: for no of SQ yards, the property is no of SQ yards. Properties provide an intuitive way to get and set values while still protecting your internal data. They make your classes professional, clean, and easy to use. Let's see a property in action inside a real class. The private field is hidden inside the class. The get accessor retrieves the current value. The set accessor assigns a new value using a special hidden keyword value, which represents whatever value is being assigned. The public property exposes safe access to read or get and write or set the value. From the outside, using this property looks as simple as using a public variable, but it gives you full control behind the scenes. How do we actually use a property? Very simple. You start by creating an instance of your class. Then, you can set a value using the setter, for example, obj.noofsqyards equal 250. When you want to retrieve that value, you simply use the getter, like writeLine, obj.noofsqyards. Reading the value triggers the get block internally. This approach ensures that setting and getting values is both intuitive and controlled, aligning with modern C# practices. This is the clean and modern way C# wants you to handle object data, intuitive but fully controlled. Why do we use properties? To provide controlled access to private instance variables, to protect data while still allowing outside interaction, to replace the old style of having separate get and set methods. Once you define a property, you can use it like a variable, but with all the power of encapsulation hidden inside. Properties are one of the clearest signs of good C# design. Let's focus on the get accessor specifically. Get begins with the keyword get and uses braces. Its job is to return the value of the private field to the outside. Example: the course name equal gradebook.coursename. Here, gradebook.coursename triggers the get block and retrieves the value. Getters are essential because they safely reveal internal data without letting users change it. Now, the set accessor. Set begins with the keyword set and uses braces. It assigns the incoming value to the private field. Example: gradebook.coursename equal introduction to computers. Here, introduction to computers is passed to the set block, and the field is updated. Setters don't return anything. Their job is purely to update the object's internal state. Here's a real-world example: the employee class, plus a method welcome message that prints a welcome including the employee's ID. Notice, the outside world sees id number like a variable. Internally, you keep full control. This is encapsulation in action, hiding your private fields while offering safe access through a public property. Important reminder: whenever you use the property id number, you're actually using the public property, not accessing the private field ID number directly. This indirect access is what makes encapsulation so effective. Control access, validate if necessary, maintain object integrity. Never expose fields directly if you want robust and secure code. Let's quickly summarize properties. The get accessor retrieves the value. The set accessor assigns a new value. Properties replace traditional getters and setters with a much cleaner syntax. Properties are not optional. They are the standard best practice in modern C#. Sometimes you want to allow reading, but no writing. That's when you define a read-only property. There's no set block here. You can read model, but you cannot change it from outside the class. This is crucial when you want immutable or semi-immutable objects in your system. Writing full properties manually can get repetitive. That's why C# offers auto-implemented properties. Example: public string name, get, set, public int employee ID, get, set. Here, C# automatically creates the hidden private field for you. It's quick, clean, and best when you don't need any special logic inside the getter or setter. Why use auto-implemented properties? They make your code shorter, cleaner, and easier to read. They remove the need to manually declare and manage backing fields. You can still add logic later by expanding them if needed. In modern C#, unless you need validation, prefer auto properties for simple data. Here's a full working example. The employee class has auto-implemented properties, ID number and salary. In main, you create an employee, set the properties, and display them. Example output: employee hash 3872 makes $22.11. Auto properties make your classes fast and lightweight, without losing clarity. Now, let's talk about how objects and methods are connected. When you create objects, remember, every object shares the same set of methods, but each object has its own data. Also, inside any method, C# automatically passes a hidden variable called this, which refers to the current object running the method. This lets the method know which object it should work on. The this reference is used in method calls automatically. Example: mycar.startEngine. Here, when you call startEngine, C# passes this equal mycar. That's how methods always know which object's data they are supposed to access or modify. Sometimes you want to explicitly use this inside your class. Example in a book class: get return this dot title. Set this dot title set value. Here, this dot title makes it crystal clear you are referring to the object's field, not some other variable. Using this is especially important when parameter names and field names are similar. Let's see two real objects in action. Book my book equal new book. Book your book equal new book. My book.title equals Silas Marner. Your book.title equal The Time Traveler's Wife. Each object keeps its own independent data, even though they share the same class design. That's the beauty of object-oriented programming: individuality and reusability combined. Now let's introduce constructors, one of the most important ideas. A constructor is a special method that prepares your object immediately when it's created. The new keyword calls the constructor. If you don't define one, C# automatically gives you a default constructor. Constructors make sure your object starts life properly set up. Here's a practical example. When you create an employee, you must provide a name and an ID. This guarantees that every employee object is properly initialized and ready to use. Finally, when you create an object with arguments, the constructor is called like this. Constructors make your objects trustworthy from the moment they are born. This is how real-world applications maintain data consistency and integrity.